Welcome, engineers. Today, we're jumping right into the precise mechanics of literally the single most powerful feature that can cut your enterprise CCTV storage bills exactly in half. We're talking about video compression codecs. If you design, build, or manage surveillance networks, this explainer is going to be incredibly valuable for you. So let's just get right into the math. Every CCTV system records video, right? But without compression, a single, raw, 4-megapixel camera streaming at 30 frames per second consumes roughly 1.4 gigabytes per second. Just think about that. If you multiply that by a standard deployment of, say, 800 cameras, you would instantly crash an entire data center network. Compression is what actually makes IP video physically possible. Anatomy of frames and GOP. To solve this massive bandwidth problem, we first need to deconstruct the core physics of compression. It really all comes down to 3 specific types of frames: the I, P, and B frames. First up, we start with the I frame. Think of the I frame as your absolute baseline. It's a complete, standalone image, honestly, very much like a standard JPEG picture. Because every single pixel is fully encoded and processed, it's the largest and most data-heavy frame type your camera is ever going to produce. Next in line is the P frame. Now, this is a predictive frame that intelligently saves space. Instead of stubbornly recording the whole picture over again, it only records the specific pixels that actually moved or changed since the previous frame. So, as you can imagine, it's much, much smaller. And finally, there's the B frame. This one achieves even smaller file sizes by acting bidirectionally. It predicts and stores changes by referencing both past frames and future frames. But the crucial takeaway here is how these frames actually behave together. Cameras don't just wildly waste bandwidth by broadcasting a constant stream of I frames. Instead, they send an initial, heavy I frame and then follow it up with a long train of those smaller P or B frames. We call this sequence a group of pictures, or a GOP. You can actually take this concept a step further with something called a long GOP. By extending your sequence up to 255 frames before requiring a brand new iframe, you save a dramatic amount of bandwidth. But, and this is a massive warning label here, a single dropped packet on an unstable network forces the camera to panic and send a fresh iframe immediately. That completely undoes all of your hard-earned bandwidth savings. So essentially, we have 3 primary flavors of GOP structure to play with. You're going to want to deploy IP for zero latency live monitoring and PTZ control. You can use IBBP for general-purpose MODA savings, and you should absolutely strictly utilize IBBP, which features 2 B frames for maximum compression on your recorded video archives. Just keep in mind that IBBP does introduce a slight delay. The evolution of codecs. Let's see how all of this theory builds into the actual codec toolkit we use in the field. Looking at the standards, H.264 from way back in 2003 is our solid baseline, and honestly, it's still everywhere. But H.265, also known as HEVC, cuts those file sizes strictly in half while maintaining the exact same image quality. Today, specifying H.265 is considered the absolute industry best practice for literally any enterprise project scaling about 100 cameras. Vendors evolved this even further into H.265+, which is also called Intelligent Streaming or Smart Codec. This variant uses scene adaptive bit rates, meaning it actively detects quiet scenes and drastically drops the bandwidth to save even more storage. Also, you really need to keep an eye on AV1. It's the newcomer codec starting to show up on Axis and Hanwha models. It's totally royalty-free, and it yields files roughly 30% smaller than H.265. Real-world storage math. Now for the fun part. Understanding how this underlying theory translates into physical storage drives and massive budget savings for your clients. Let's run some typical industry examples. We'll assume a standard 4-megapixel camera running at 30 frames per second, recording continuously 24/7 with a 30-day retention and targeting a 4 megabit per second bitrate. Now, I have to stress this. These are typical baseline numbers. Your actual real-world results are always going to depend heavily on your specific scene complexity. But just look at how drastically the monthly storage footprint steps down. For a single camera per month, H.264 demands about 1.3 terabytes. Upgrading to H.265 halves that immediately to 650 gigabytes. And deploying H.265 Plus with intelligent streaming, that slashes the requirement all the way down to roughly 325 gigabytes. Now, let's scale those exact assumptions up to an 800-camera, 5-star hotel project. If you stuck with the old H.264, you'd need around 1 petabyte of storage. 1 petabyte. But by moving to H.265 Plus, your storage requirement plummets down to just 260 terabytes. That staggering 75% reduction is a huge deal. That is quite literally the physical cost, the cooling requirement, and the power draw of an entire enterprise storage rack completely eliminated from your project budget. 3 golden engineering rules. Let's synthesize everything we've talked about into actionable engineering directives for your next system architecture. Rule number 1. You absolutely must mandate H.265 Plus in the bill of quantities for any system over 100 cameras, and you need to include explicit bitrate optimization settings. Rule 2. Restrict long GOP strictly to rock-solid network backbones. If you're on Wi-Fi or a congested network, dial it back down to GOP 60. And Rule 3. Live PTZ strictly uses the IP GOP structure while recording uses IBBP. Seriously, do not mix these up unless you want terribly juddery, laggy camera control. Furthermore, remember, you have to match your intelligent streaming profiles directly to the scene. Intelligent streaming thrives on periodic activity. It's going to yield massive data savings on something like a quiet perimeter fence at night. But you'll see much lower savings in a busy 24/7 active lobby. This is exactly why using carefully tuned vendor defaults, like Bosch BVMS's balanced standard profile, which runs GOP 60, IBP, and medium intelligence streaming, is incredibly useful for most projects. So I'm going to leave you with this final provocative thought to take away from this explainer. Codec choice has a bigger impact on overall system cost than any other engineering decision you will make. Will your mastery of these codecs save your client $1 million real? Or will your oversight fund a massive rack of spinning disks that just sit completely idle in a server room somewhere? Keep building those engineering skills, and I'll see you in the next one.